Hello everyone, we're back with another game engine coding stream, I guess. Last time we set up our devices, a physical and logical device, set up a queue, and we got our swap chain. No, not swap chain, we got our surface, I believe. Let me double check that. Yes, we do have a surface. So we got something going on. Um, let's start our code left. There we go. Um, we got our surface in a Vulkan, create surface, yada yada yada. We already have the queue family, presentation queue. Um, queue, create info to size and queue data, presentation, presentation support. Yeah. Okay. Just double checking everything, making sure we got everything here. And it looks like we do have everything, so that's good. We can skip the Windows Surface. We can move straight onto SwapChain actually, which is quite exciting. So with the SwapChain, we just need to create images and then tell Vulkan how to swap them out really fast, basically. We already queued this SwapChain extension name for our device, so we can skip that. Um, there's some extension. No, we already loaded that extension. Um, so we can just go ahead and create a new file here called Vulkan SwapChain. And go ahead and set up the defaults here. So pragma once, namespace. And then class Vulkan SwapChain. So I'm pretty sure we need an instance, so vk instance Vulkan SwapChain constant vk instance reference instance instance instance. Vulkan SwapChain and the destructor. I'm actually gonna do a void init here. We do have a couple things we need to initialize. And then we can just do support details, extract to keep track of our support details. We need the service capabilities. I am not good at spelling. VK surface format HR. and then VK present nodes. Make sure there are actually class names in here. Where's flag surface format. So it's just format. Display mode. Yeah, so that is a thing. So in this SwapChain, this is correct. And then, give me 1 second here. Exception thrown at. Uh, trying to access. Yeah, definitely look at your code, but yeah. Sorry, I'm helping someone here. I'm not gonna, don't give him hate. He's new at C++, and I'm trying to show him his ways. But here, he's having an error right here at textures at name, and he's getting a deception um at this memory address, access violation, reading location, nothing. And that means textures at this right here somewhere. The function at is trying to access null, or you're returning null. So yeah, it's it's a common mistake, I guess. Um, let's see here. Let's respond. So how could I tell? Let's see here. And it Uh, access function, reading location. So yeah, null pointers are yeah. Top is returning a null pointer. I don't know why. Um, is this the states? Yeah. But anyways, back to my code here. So vector formats. Present modes and then format. What is format? HR. It wouldn't be a struct, it would be a enum class or HR. I'm assuming it's just I don't know if a caching. Let's see here. Yeah, BK format is the right place. So when we initialize, no, we haven't done anything. Anyways, format present mode HR. That's pretty much it from that. So when we initialize, we need to get our swap chain or the details here. So let's create a new file. PPP. And I'm just gonna copy the top few lines here. Vulkan SwapChain. Vulkan SwapChain. Vulkan SwapChain. Void Vulkan SwapChain. Vulkan SwapChain Destructor. So, what we need to do first, we can query, but let's cache it. We don't need to create a new one every time, so we don't actually need a instance actually. We just need a device. There we go. So yeah, once we get the device and initialize it, we need to device. Okay. And this also returns a VK swap chain. HR. And we'll have images, so don't need to worry about that. Um, Hey, at least he found what happened, so that's great. A lot of people don't understand access violations. So um, when he's accessing states.top, it's returning a null pointer, and once you start accessing anything at null pointer, it's gonna give you access violations. And having like a big code base, it's really easy to forget that it hasn't got initialized. Especially when you're new to C++. So I see what happened. It's a great feeling. And I'm, even me, like, I only been programming in C++ for a year. That's a great feeling to see. But anyways, so Destructor, Vulkan SwapChain, device. So my device, it's not a pointer. We need to get physical device surface formats. Okay, get physical device surface formats. So we might need to get the physical device. Hold up. Unless the logical device is in another variable. Let's go back to the setup here and look at logical device and queues. VK device. Okay, so we can just ignore that. And actually, I look at my swap chain. Surface, device, and swap chain. Details.autofill. Okay, we do need the physical device here. And surface. Um, const, VK physical. PD and const VK surface HR reference. Oh, right. So we do need to add this function in. All right. So details on autofill. There should be an autofill. Wrong class. Duplicate tab. Or wrong file after. Vulkan.hp. Autofill. Okay. So in this autofill, which kind of needs some our capabilities. The PD dot get surface capabilities HR, and it takes a surface format PD get surface format HR surface and present mode. And it's actually surface present modes. There we go. Correct spelling helps. And then I'll take the surface, so there we go. Question is, should I keep this here? Because we can actually implement all of this in the device. And then we can just say, hey, here you go. I'm gonna just keep it as is for now. We can always switch it later. So I can divide. There we go. And then we need to do include Vulkan context. No, we don't need context because we're not using it. Physical device, surface. Surface. And then we initialize, we need to get the physical device and surface. So all right. So we initialize, and that should be okay. We just need to say, and then we do details up, or in it actually, PD and surface. All right. So we got our support details. Back to our swap chain. So we got our capabilities, formats, and present modes. We would like to go through and use the most available one. Let's see here. Get physical to find surface KHR. Formats is not zero. We fill it in present modes. Same with the present modes. We should check if we get everything. So in the init here, to check if everything has been set completed. But I'm not gonna do that. I'm lazy. Surface format. VK surface formats KHR, choose SwapChain surface formats, and variable format. All right, so this is where we can choose our actual format. Um, uh, and choose extension. So we're gonna have these as virtual functions and protected. Format, present, and extent. And these are like what we're gonna define here. So pretty much copy these lines here. Paste it down here at the bottom-ish. Get rid of virtual here. And then we need to do Vulkan swap chain. And add parentheses. There we go. So we can now do this, choose format, this, choose present, and this, choose extent. So our format, I'm gonna see if I did for the format. Yeah, so for the format, when we choose it, we need to force, yeah, we need to loop through every available formats, and find the RGB and sRGB format. So and now I'm gonna put it down here. VK format for const auto reference format in details of formats. So we're looping every format. So if format dot format equals vk format er8 g8 b8 srgb and format dot color space is equal to vk color space hr srgb non-linear then we assign it to our format. And then we break out of this state because we don't need to do anything. Otherwise, format equals details at format. We use the first one. For presentation mode, we would like to query, but present mode vk present mode hr immediate basically push as much frames as you can. Yeah, I'll keep rendering. There's different kinds of preset modes. So present modes here. Let's see. There's good visuals, but I'm not sure. Rendering and presentation. Here we go. Actually, no, it's going to be in the SwapChain equation. It's later. We want to present SwapChain surface format. All right. Here's some text here. So immediate images supplied by your application will be transferred to the screen right away. Like I said, it's going to push as much as it can to the screen, and we don't care. It's going to result in a lot of tearing, as you can see. So first in, first out. it's okay. So first in, first out, it'll put in a queue. Everything that's put in first, it'll get out first. What it means is like first thing in, first thing out, basically. Um, this is really better for the graphics card as it's almost like VSync here. Yeah. The relax KHR, only differs from late and the queue was empty. Okay, so if the queue was empty, it'll yeah, so instead of waiting, you'll transfer. So if there's no image in the queue and we push an image, we'll just grab it right away. That's what relax KHR is. And then the mailbox, instead of blocking the application and when the queue is full, the images that are killed will be simply replaced by new ones. Okay, so this is the better one, as it just, you'll have like a buffer of different images, and it just overrides it and take whichever ones that's most available, I guess. So this one is, I guess, the one that we want, but we gotta make sure we can use it. So yeah, let's implement it ish. So what I like about immediate, it gives you like your theoretical maximum of your FPS. But it's not really practical as you're wasting your GPU performance. So that's why we need to use VSync. Reference the sales that present modes. So if the mode equals VK present mode HR, present mode HR e mailbox. Then we actually want to say mode otherwise we want VK present mode HR e first in first out. Make sure that's all good. Present here we go. Immediate mailbox FIFO relax. So immediate mailbox FIFO. I'm actually gonna use the, instead of immediate, we can use the VSync option. Because it's gonna be good for the graphic cards, I guess. Now our extent, this is basically saying this is our screen. So here's SwapChain extent, surface capabilities. So if the width is more than extent, yes. Is that the one that they have? Sorry, I'm comparing codes here, so this is what I have, and this is what they have, and I'm wondering if it's the same, which actually looks like mostly the same, minus the, yeah, it's the same here. Practically the same. So what the extent is our screen. Current extent, the max, the min. Okay, so these are the images that we are rendering to. We can get the minimum and maximum images. These are our like image buffers, I guess. And we need to actually create it here. So what I can do is copy and paste what I have. And then change some of these. So details, capabilities, the current extent, the capabilities, the current extent, width is not more, it's not the 32-bit maximum, meaning that we're not going to overflow, and then we can just use it. Otherwise, we want to predefine our screen size, the axle extent, and then we clamp it to what we have. We do need to change these variables to match our details. But yeah. And we're done for the extent. All right, preset mode, extent, and format. Make sure that's in here. Preset mode, KHR, extent 2D. And then we need, and that's it for our main SwapChain, I guess. Double check everything. Yep. We do need an image count, so UN32T image count. And this will be our image, SwapChain images. And now let's actually create our SwapChain. That's new. Okay. That's actually new. I like that actually. So auto create info, VK swap chain, create info KHR. And what we can do here is VK swap chain create flags as the first argument. Set create flags. Uh, SwapChain create info. There we go. Create HI flags. Oh, that's a thing. We can just use that function. Device swapchain.cpp. Use that function to create our flags. For the most part, swapchain create info KHR. Everything should line up with what Vulkan set out here. So the first part should be a surface. When we initialize, we do have a surface. So surface. Minimum image count. Image count. I'll just use image count here. And we can actually just query this from our details. Got I think we already did this actually. Did we? No. Capabilities that min image count. We actually do want the max, but eh. So we do have a minimum image count, so image count format 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 space extent array layers 1 usage VK image usage flag bits e color attachment composite alpha no minimum image count image format color space extent array layers the usage one layer the usage so the usage it will be a color attachment yep with the usage it will be the pre-transform let's check that sharing mode we do have different sharing modes. That's we could query this later. I prefer to do this now. I'm gonna say just use it as exclusive. Oh, right. Exclusive. Extends formats and that. Image count. Attachment bit. Yeah, so they want us to use concurrent if it's not equal, but exclusive if it's equals. And I'm just lazy and not do them both, actually. Transforms. Back here to Q family index counts 0 change if we concurrent. And then no enter P concurrent. The pre-transforms. Here we go. Pre-transforms. We do have details dot capabilities dot current transform composite alpha BK composite BOP and then present mode would be and then clip BK and then no pointer. Everything about all this could be a little bit complicated, especially when it's me trying to explain what's going on. It's all right here in the Chronos Vulkan documentation. Really look at this because it could be wordy at times, but hopefully it works for us. We got everything there. Now we just need to use a device to create our swap chain. So device create swap chain using our create info and then storing it under swap. There we go. We do need to later on create our image views and images, but let's see if we can get this compiled at least. We do need our swap chain, so inline const bk swap chain khr reference to get swap chain. There we go. It's swap chain format. And there we go. Format, present mode, stamp, and swap chain. So once we initialize, we do want to, in our Vulkan context, only have one swap chain. So in the context here, insert surface create swap chain. We do want a Vulkan swap chain pointer. And we do need to destroy it. So after we create our swap chain, we do want to destroy swap chain. So device destroy swap chain khr this swap chain. But anyways, Vulkan context.hpp swap chain, and then go to definitions and the CPP, and let's create a swap chain. So swap new Vulkan swap chain. I'll take in a device. And it's actually a pointer, not a and then swap chain init. And every time we call new, we need to call delete, so delete swap chain init. Let's initialize it with device get physical device, and then surface. And that should initialize our swap chain ish, because I am actually forgetting to include. Alright, go ahead and make this. We should have our swap chain ready ish. You can change that. And guess what? We got only one error, which is good so far. Context. Get off W. Oh, wait. Here we go. I forgot to create that swap chain. There we go. There's our errors. So, get surface formats. KHR. We can come back to that later. Actually, we can come back to it now. Okay, we can come back to that later. Let's start up from the bottom. Formats 0. So choose formats. Formats 0. That's done. Color space. And format is not a class type. Surface format KHR. That's what I want. And Technoblade is live. Technoblade. Format. Wait, swap chain, KHR, copy that. CPP. Swap chain. E exclusive. 5 bits. Present mode. HR, present mode. So I don't know what this one is talking about. Let's build it again. Format format. And this is a dot here. Format that format. Surface format KHR support details format. Oh. KHR. There we go. That should fix some of the errors, I guess. SwapChain. Get surface present mode. And add it. What else? Surface present mode device is not declared. PD. And use but not. Or is it redeclared? Yep. Redeclared. Don't need it. Window GLW. Core. Oh, right. So finally got link. Let's see if we got it correct. So far the foundation layers is not saying anything, so that's good. And we exit just fine. So that's pretty much it for the swap chain. Let's do a little recap here. We actually did not, and well, we did initialize her. So yeah, we actually created that swap chain almost on the first try. If we got the compiling, we would have done just fine, but yeah. Basically, what we did today was create a swap chain, which tells Vulkan how to swap the images. We might go into, well, actually go into creating the swap chain images tomorrow. And yeah. But anyways, we got, basically what we did here was get the details from our physical device and surface stored into this structure here, and then we go through process. What do we want? We want an RGB and nonlinear format, and then we also want how fast, so VSync or not, and then our extent, and that would be our picture width and height, basically. We put into our create info saying that we want the regular flags. Here's our surface. We want the number of images, so whatever our capability says. The format, color space, the extent. We only want one array or one image layer that's using a color attachment. And this, we're using an exclusive, so both our graphics and present has the same thing. Don't need to worry about the Q families or the array. And then we do give it the current transforms, say that we want the opaque, so we can see through. Give it the present modes, clip enabled, and we don't need to give it an old swap chain since we're creating a new one. and we just create one. Once we're done, we just destroy it, and we're good. So that's SwapChain. We just tell Vulkan, hey, this is how, if I go back down here, just tell Vulkan to create it once we start up. And that's pretty much it for the SwapChain part of this. If you have any questions, let me know. Hit me up somehow. I have a Discord server. Always come there. And yeah, I hope you all have a great day.